Hello friends, in this video we are going to discuss the next four static characteristics of measuring instruments. In that, first one is resolution. Okay, what is the resolution? Resolution is nothing but the smallest change in the input that can be measured by the instrument. Okay, so it is smallest change in input, smallest change in input that can be measured by instrument or the measuring instrument. Okay, this is the smallest change in input that can be measured by the instrument. Okay, that is nothing but the resolution. Okay, so suppose, or it is given that it is given as resolution is equal to full scale deflection divided by, yes, total number of divisions. That is nothing but the resolution. Okay, resolution. For example, suppose we are having this type of voltmeter or the scale. Okay, suppose this is a 0 volt, this is a 5 volt, this is a 10 volt. Okay, and here we are having a pointer. Okay, we are not having the subdivisions, right? We are having only 3 divisions, for example. Okay, so now what is the smallest change that can be measured by the instrument? Smallest change in the input that can be measured by the instrument. Yes, after 0 the next division is directly 5 volt. Okay, so the smallest change, it should be equal to 5 volt. Okay, so this is what the resolution. But suppose if we divide the scale into subdivisions, right? For example, okay, like this. Suppose this is 0 volt, this is 1 volt, this is 2 volt, this is 3 volt. Okay, and so on. Okay, so this is 0 volt and here it is a 1 volt. Between 0 and 1 we are having the 4 subdivisions. Okay, so can we say that if this is 0, this is 1, so one subdivision, it indicates a 0.2 volt, next one will be 0.4 volt, etc. Okay, so what is the smallest change? From 0 it is directly 0.2, from 0.2 it is directly 0.4. So what is the change required? It is equal to 0.4 volt. Okay, so the resolution is nothing but the smallest change, so that's why it is equal to 0.4 in this case, 0.2 in this case. But whereas if the subdivisions are absent, the resolution will be equal to 5 volt. Okay, so simple one, this is the resolution. Next, dead time. Next one is the dead time. Dead time, right? As what is the dead time? Yes, it is nothing but due to the moment of inertia of the pointer. Okay, so the pointer generally takes some minimum time to start from its 0 position because of inertia of the moving system, and this minimum time is called the dead time. Okay, so dead time is nothing but generally pointer of the instrument takes some time to start from its initial position, or the 0 position. Why the pointer is taking some time? Due to inertia of the moving system. Inertia of moving system, right? Inertia of moving system. Okay, and this minimum time is nothing but the dead time. This minimum time is called the dead time, right? And suppose initially the pointer is at the 0 position, and if we put some input if we connect some input across the instrument, then whether our pointer will move from that zero position to that true value within a zero time, not possible. The pointer is taking some time, and that time is nothing but the dead time. Okay, next one is the dead zone. Dead zone. Okay, dead zone. Dead zone is nothing but for a large change in input for which there is no output at some portion of the scale is called the dead zone. Okay, for a large change in input, for large change in input for which there is no output, no output for some portion or at some portion of the scale is called a dead zone. It's called a dead zone. Okay, so are you getting the point? Okay, so dead zone is related to the some portion of the scale. Okay, dead time is related to the response of the pointer. Okay, so this is the dead zone. Next characteristic, it is linearity. Linearity, it is very straightforward. It is related to the linear shape. Linearity, yes, linearity is nothing but for the instrument, if the output is proportional to the input, then it is known as a linear input, a linear instrument. Okay, if output is proportional to input, then it is known as the linear. So here we are having the output and input. This is input and here it is the output. Okay, so it will be like this. Okay, output is proportional to the input. So this type of the scale, if the instrument is having at linear scale, then it is known as the linear instruments. Okay, this is about the static characteristics of the measuring instruments. Thank you.